My favorite lecturers here, Leyrer and MacLemon, will be holding the lecture called Advanced SSH.
Welcome. If you've been to our previous lectures, we switched a few things around just to confuse you. So on your left this time is MacLemon.
Hi, and to your right is Leyrer.
Hi.
We think we should be talking about advanced SSH.
For several values of advanced, that was a topic for heated discussion on Twitter and at some other conference. What is actually advanced, and some people, the opinions differed rather.
Yeah, they differed.
They differed.
So we'll start with a quick overview of what we'll be not covering. So if you're interested in those, you're in the wrong talk.
Or if you have a friend who's interested in those things.
Yeah, they're not here anyway. So we'll focus on OpenSSH because we expect this is what most of you will be using anyway.
If you're using an open Solaris version of SSH,
yeah, you can install OpenSSH on Solaris as well. So we won't be covering the .ssh config file, which you already are using, I expect. We'll not go into depth with that. We'll use, but not go into depth in public key authentication. You're already using that, I'm pretty sure. If you're interested in advanced SSH things, so you have ED 25519 or RSA keys in use, to prevent successful monster-in-the-middle attacks or brute force attacks to your servers. You maybe have already heard of port forwardings, local forwardings, remote forwardings, X11 forwardings, and dynamic forwardings for a SOX proxy on the fly. And you already know how to copy files back and forth using SCP or SFTP, or if you so desire, rsync, and you surely are familiar with the standard tar rainbow pipe compression pipe view, which gives you not only a nice rainbow, but also a nice progress bar on how fast your copy is going, and of course the standard SSH speed test, how fast your pipes are working. So, if you're still with us, that's fine.
if not stay, it will be at least entertaining.
That's what you said.
Yeah.
The things we show you are a few things we use in our daily work as a bastard operator from hell. And of course, everything is 90-11% certified as works on my machine, as usual. So, interested in security configurations for your SSH client and server, of course. There's a bunch of things you can do, and you probably never looked into this, or you have. Hopefully you should.
You probably haven't, if you're not MacLemon, you haven't looked at this. So.
Some people. At least after this talk you will. Of course, SSH uses some key exchange algorithms to establish the connection. The config keyword is kex algorithms. And if you don't know which algorithms your SSH client supports, you can ask it. Dash capital Q, kex, and this requires SSH 6.3 and higher, and you get a friendly list of key exchange algorithms. This is the current version 7.3 of OpenSSH, what it does support. There's a bunch of things, and to know what you can configure or what you should configure, from my point of view, we'll drill down that list a little. So there's a few things ending in SHA-1. Of course, we should not be using SHA-1 anymore. It probably won't survive this year, so we'll cross those out. The Diffie-Hellman groups, group 14 of the Ike groups, it's a 2048-bit group. The higher groups are larger. Anything less than that, we strike out, of course. And yeah, we get rid of those. If you don't like the NIST elliptic curve because you don't like NIST or you don't trust NIST, you can get rid of those as well. And any hash function that is below SHA-384 is also not recommended to be used anymore. So SHA-256, if you want to go high security, get rid of those as well. And if you, but for me personally, I think it's fine to go with SHA-256, that's still okay. And if you leave in the Diffie-Hellman group exchange, key exchange algorithm, you gotta edit your SSH moduli file, which is a bunch of primes that your client and your server uses to connect. And it looks like this. Of course, it's much larger, and you could even see less of that. There's no need to take pictures of the moduli. They're on your system as well, so that's fine. If we zoom into this, you get a nice state stamp from when that file is. And the fifth column shows you the bit size of the primes. Anything below 2000 bits you should get rid of. You can just comment that out. The current OpenSSH 6.0, current OpenBSD 6 release, which uses OpenSSH 7.3, has everything removed below 2047. So that's something you need to edit on the server and the client. Both have to agree on these common primes. So for configuring, we'll end up with this CAX algorithm list in that order. Of course, the curve 25519 is the Daniel Bernstein curve. It's really fast to use. It's a safe curve, and the other ones as a fallback, depending on what your server or Wi-Fi LED bulb or your toaster supports. This is how you enter this in your SSH config file on the client. You have the host star, which is your generic configuration that applies to all your host entries there, and you just put that in on a single line. That's fine. You can use the same configuration in your SSHD config file on the server, just without the host star line. Yo, that's it.
Just make sure that all clients that will connect to that server will support at least one of those.
Yeah, you will notice when you don't agree on things. It will just not work anymore. So take care before you reload your SSHD server, before you lock yourselves out. Of course, there's key types. These are used by the client to authenticate the server and check the fingerprints. And of course, they have to be mutually supported. You can, again, if you run SSH 6.3 and above, you can ask your client what it does support. Of course, there's a bunch again. Of course, we don't want to use DSS, which is a DSA version, or elliptic curve DSA versions anymore, so we strike those out. That was easy. And you'll end up with a pub key accepted key types configuration line. We'll gladly accept ED25519 elliptic curve keys from the server in signed versions with a certificate, or just as a host key, as I guess most of you won't be running their own PKI. And yeah, for fallback, we use RSA, which is the most commonly used still. If you can get rid of RSA, go the ED25519. It's quite simple. For message authentication, that guarantees your integrity of the messages. There's also multiple versions of those. You already, sounds familiar? Looking good. If you're on older versions, you can get them as well. It's not that funny, but it works. It gives you the same list. We can also drill that down again in the same manner. We don't want to use SHA-1 or 96-bit shorted versions of SHA-1 or MD5. We'll get rid of those. We don't want to use anything that uses a version other than encrypt then MAC. So first we encrypt and then we get a message authentication digest. We get rid of those. Everything below 128 bits is write out. And we end up with this list of MACs sorted by strength. There's no need to remove anything that's not that strong because there's no downgrade attacks available. So you can happily just use that one. Of course, after all that authentication and agreement, we end up with a symmetric cipher that we actually use for encryption of the stream. You can ask SSH what it does support. There's still a ton again. You already know the drill. We get rid of everything that uses only 64-bit blocks, which is triple des, it's blowfish, it's cast. We get rid of those. They're from 1976. Almost as old as me. Of course, we get rid of...
Talk for yourself.
Yeah. We get rid of everything that uses cipher block chaining mode, CBC mode. And RC4, we all know that is broken. We get rid of those as well.
Let me just add, with Blowfish, if you search the Googles, you will find introductions on how to make X11 forwarding faster. And one of the tips you will find on Google a lot is restrict the ciphers to Blowfish or something similar. These are all old guides. Please don't do that anymore.
Yeah,
it won't work.
Yeah, your performance will be fine. Trust us. Blowfish is a cipher originally created by Schneier, and he himself recommends to not use his cipher anymore because it's old and broken. So,
should give you a hint.
Yeah. So you end up with a ciphers string. The Cha-Cha-20 Poly 1305 is a very new cipher. It's supported since SSH, I think, 6.4 or 6.5. It's a very fast cipher. It also works well on machines that do not have AES hardware instructions, like the ASNI instruction set on Intel chips. It's extremely fast on ARM, so if you're on your phone or just a small embedded board that are pretty common these days, or a ThunderX 96 core ARM monster, this is really fast, so don't worry about your performance. And the other ones are AES in Galois counter mode, is GCM, and counter mode CTR, also sorted by strength. If you only want to use the so-called authenticated encryption with associated data, which means it doesn't need an additional MAC for message authentication, you can get a shortened list by cipher auth, which means you'll end up with just the GCM modes and Cha-Cha-20 Poly 1305. Of course, these are in the order SSH gives them to you and not the one you should configure. Take that from the other one. Still with me? Yeah, that's a lot, I know. You'll get the slides, you can copy paste from there. Just don't lock yourselves out. On to more funny things, entertaining things. This is security stuff. I know it's tedious, but it helps. Anyone using two-factor authentication? Oh, there's a bunch. Okay.
For SSH logins.
For SSH logins. There's still one. Yeah, okay. That's great. Two-factor, that's nice. That's how your users can authenticate against the server as well. Public key authentication is fine, but you can augment that with a second factor. Of course, you can buy RSA tokens. They're pretty expensive. They use some strange random number generators that are probably not that random. They're inconvenient to carry around. People tend to forget them, to drop them, to lose them. There's creative ways to get around that. So if you lose your RSA tokens, don't carry them with you. Put them somewhere safe. Flip up a camera. Picture quality these days is fine enough for computer vision to actually read the numbers. And if you need more than one, yeah, stick them to a cardboard.
If you need more examples, try a search on Show, then you will find quite a few of those tokens.
Yeah, so find your friendly webcam and see what happens. Of course, generically, RSA tokens are just time-based one-time paths, which means there's a pseudo-random function initialized with a seed random value, and every 30 seconds, it changes the value that you need.
What he actually means is there is an app for that.
There's an app for that. There's probably multiple. One of those apps with a standardized method of calculating these things is Google Authenticator. If you don't like Google, there's other apps that implement the same algorithm. You can easily get that for free. And
so as they're time-based, you don't need an internet connection to use that.
Which is quite convenient if you're in the data center and your phone does not have internet reception there, because at level -3, GSM gets really bad. You can use that in flight mode. That works just fine.
Installation is even simpler,
Yep.
at least on Debian.
On Debian, on any Debian flavored tux, that is easy. If you prefer the BSDs like me, there's 2 ports you can install. Yep. That works just as well. And now you need to tell SSH that it somehow has to react to two-factor codes.
This is really, really hard stuff. It takes you at least a whole weekend to configure, trust me.
Yeah, because
Yeah.
you spent the whole day, both days at the conference talking to people instead of working on that.
Yeah, or trying to exit Vim. So
Yeah.
So what you actually have to do is you have to edit your SSHD config file for PAMD and add an additional line telling PAMD that we are using the Google Authenticator module. At the beginning, you will probably want to add an additional parameter to tell it to, which is called null OK, which tells them to ignore any errors with the PAMD module until you have all your users on the Google token or to Google application, so to say.
Yep.
So that's the one configuration. It's adding one line. It's really, really hard work. So
Yep.
build a customer 8 hours.
At least.
Yeah.
As a week. During the weekend, preferably.
Yes,
bonus money.
double time. Second configuration is, of course, the SSHD config. What you need at least is the challenge response authentication turned on to yes, otherwise it won't work. The other stuff is basically if you know that it works and you don't lock yourself out again, so you have set up your public-private key authentication, you're sure you can still access the machine once you enable two-factor authentication, because with that you can't log in without the second factor.
Yeah, so this is what you have in your config after everything works, and you have double-checked that it actually does. Do not do this before setting up Google Authenticator.
I mean, you're all responsible admins, so
yeah.
We're just reminding you of the best practices.
Exactly. And to initialize Google Authenticator in your terminal for a specific user, you log in as that user and just run Google Authenticator. And for this, we will switch to a live demo. So,
who's typing? Should I type?
Yeah, type. Please type.
So we're just starting Google Authenticator, and Google Authenticator, the client-side program, will ask us a few questions and will generate us a key that we have to enter into the application to synchronize those two elements. We have something prepared for this, or do you? Okay. So let's just start the Google Authenticator, and it asks us, do you want to use authentication tokens based on time? Yes, because we are time lords. And then it creates a whole bunch of gibberish and a new secret key, which you haven't seen. I will have to blitzdings you afterwards. And of course, there is the emergency scratch codes. No, don't scratch on the screen. These are just called that way. These are your emergency codes in case your phone gets lost. You can't use the synchronized Google Authenticator again. With that, you can rescue your setup and log in again.
You can use these codes to log in even without your phone. So have these ready in case your phone gets stolen, lost, caught in a fire, whatever. You have a few more logins to use, so you can at least reset up Google Authenticator, get new tokens, or turn it off, should it be necessary.
So the next question is, do you want to update your Google Authenticator file or create a Google Authenticator file? This is the configuration file that gets written into your home directory and which the PAMD module will use to verify the code. So we will say yes in this case because we want to show that it actually works. Do you want to disallow multiple uses of the same authentication token? As we are demoing at the moment, we just say no. Yes. Yes. Yeah. Yes. Do you want to disallow? So we allow multiple users. Yes. And there's also, if your time servers are not that current, you can skew around with the timing. We do want this as well. And to harden against brute force attempts, we can enable rate limiting, which we won't do at this moment. So that's all done. We are basically done with the setup on the so-called client side. All we have to do is now tell the application on the cell phone the secret key we have seen before.
So that will, if I manage to get that window there, what you can see here is the screen of a phone, and you have the Google Authenticator icon. We could launch it, and yeah, probably should have done that before. So it says, welcome, you want to set up two-factor authentication? Yes, we want. And we'll say begin setup. And then you have two ways of setting that up. And to show you which way these work, I have to switch over here, get rid of that one. And we're using Tmux to demo, so I can scroll back. Of course, we have the secret key as a code you can type. That's rather inconvenient and slow, and of course you probably will make a typo. But you get also a QR code generated in your terminal. That's convenient. Probably the only sensible use of QR codes anywhere. And I can just say scan barcode and go here, and it should scan the barcode. Yeah, and I'm all set. This is it. It's really that simple. And now you see SSH host 01, that's the one the name of the host we use. When it starts blinking red, you only have a few seconds left to use that code, and then it generates a new one. The small indicator on the right shows you how long you have until the next code appears. And of course, you can rename those, because if you have the 27th SSH host there, you won't know which one to use.
So
that's pretty simple.
So basically what you also see is that this tool forces you to use a code for each server, a separate code, so you can sort them around, the ones you use more often.
Yeah, you can sort them if you so please.
All right, so let's show you how this works. Can you switch back to the other terminal?
I can switch back to the other terminal, and I will do this, and I will do this, and we're back here.
Hooray! So could you scroll down as well again?
I need to scroll down.
Ja, dann alt das immer so mühsam. All right.
Yeah.
So
yeah, here we are.
Here we are. So let's log out of that machine again. So I'm back on my workstation, and now I try to log in again. So I'm doing an SSH host 1. Okay, give me a second, because I prepared something else for later, and so let's try again. So I told SSH to not use a key file, and we should get the normal username password prompt. No. Then SSH agent. Entertain them.
Of course, with every login on a shell, you should have a fortune or cow save. It's a cultural thing. Every server should have that. It's mission critical. And it also helps to keep people entertained while Martin is typing. Desperately trying to get rid of SSH agent, which you all should use. If not, make a note of that. SSH agent is awesome. Killing spree. Okay.
Let's try again. Yeah, a lot better. So we're now connected to the server, and it prompts us for a password, which we will enter, and it now asks for the verification code. Could you please show me the verification code? Which is 044190, and I'm logged in. So that's two-factor authentication. Takes at least 3 days to build to the customer, tell your boss, I need 3 days to set this up, I need a week to set it up.
But it all pays because you're not buying RSA tokens, so it's a really cheap solution.
Yeah. You can also combine this with key exchange. You can have a key authentication combined with the time-based factor authentication. But usually you do it as a fallback for your username password authentication to augment that with a second factor.
Yeah, you can pretty much mix and match multiple types of authentication, like password interactive plus authentication token, or just an SSH key. That's also possible. So you have a fallback method. If you cannot access your keys, you can still log in with a password, but then you need a second factor.
All right.
Yeah.
Excellent. So on to the next topic. Should we switch over to the slides or just stay in the show?
The slide would just show you bastion hosts, which means you hop over one host to another host, and that's about the slide.
So that's one of the things at least I as a sysadmin have to do quite often. Customers or even internal departments set up a so-called bastion host or firewall, or you name it, whatever you want. So you have to connect to the first server, and from then on you can then hop into a server that is within the firewall, within the local area network of your customer or your company. So the Padawan way to do that would be to SSH into the first host. Let me just... SSH.
Of course, you should have set up key authentication.
Okay. Oops. What's going on here?
It just asked for the key passphrase.
Nope.
Yes, it did.
I love you as well. Don't SSH. Don't pressure me.
No. It's just 100 people looking.
Yeah.
No worries. So fine. They're friendly.
Okay.
They're still friendly.
Now we're here.
Okay.
So I connect to the first server, my bastion host, and then from then on I will connect to my second host, Leyrer2.example.com, and I haven't set up the keys there, so I'll log in with username and password, and I'm now on my second machine.
Yeah.
On my second machine. So that's the normal manual way to do this. This is rather boring. This is cumbersome if you have to do that several times a day. This is really, really, really boring. The nice thing is that with the most current version of SSH, SSH offers us a nice new option called jump host, or proxy jump, which will simplify this activity enormously. So you just give it the option -J and the name of the best of the first or of all the jump hosts you want, and as the last argument the target server you actually want to connect to. And
So-
what SSH will do? Yeah, please go on.
So SSH is gonna make you jump.
Jump. Bad 90s songs for 500, yes. So you can not only jump through one host, but through several hosts until you reach your destination. So if everything works as expected, this should connect us directly to the host number 2. And it actually does, as we can see in the bottom corner, in the last line of the shell. So it's easy, it's fast. I don't have to type that much. And if I exit that connection, it will tell me that the connection to host 02 has been closed. So I don't even see how many hosts I jumped through to get to my final destination. No. Of course, this can be even now. We're still playing SSH golf, so we can shorten that even more. and just say, for example, proxy jump, and it will do the same thing. What I've done here is I've made an entry in the SSH config file for the proxy jump, giving it the host name, the username it should use, the identity file it should use, and of course the proxy jump statement giving the bastion host I want to connect through, and the host 01 is the entry up here, also specifying identity file, user port, and host name. So this is only available with SSH 7.3. Yep. If you're on older versions or slightly older versions.
Nobody uses older versions of OpenSSH, I'm sure.
Yeah. For those that still have to struggle with those, there is something called SSH standard IO forwarding, or minus W, that will bounce you through to the through the intermediate host to your destination, and will basically forward the standard IO channels to your client. So the command is a little bit more cumbersome. There's a proxy command which basically tells it use the SSH connection to host 1 to bounce through to the destination SSH host 02. This should work as well. It did in the morning. Again, I'm connected to host 2, as you can see in the bottom line. Syntax is a little bit more explicit, but still works quite fine.
Of course, you can use the proxy command part you've seen here, entered directly on the command line. You can put that on your SSH config as well.
You mean like this?
Yeah, exactly. Why are you so prepared?
Sorry for that. So again, playing SSH Golf, SSH PC gets us the same result. If you don't even have standard IO forwarding, which some SSH clients do not support, you can force a TTY allocation, which will basically do the same thing as the standard IO forwarding. Instead of -W, it's -TT, and with this you don't get the authentication forwarding. You just get the login prompt, and then you're also logged in on host 2. You see, there's one drawback on for this method, and with this method as well, I'll see all the connections that actually get open. So it's SSH host 1 as well as SSH host 2, as you can see in the bottom lines. If your host is even older, which means Sean Connery mode on, which means SSH 5.3 or lower. So we're really talking about ancient software by now. You don't have TTY forwarding, you don't have standard IO forwarding, you don't have -J. What you need is netcut, and you can then use netcut as a proxy to proxy through to the bastion host to the destination host, and again you are connected to SSH host 2. Works as well, and of course there's also the possibility to put this into the SSH config file.
So by now you have realized you should really upgrade to OpenSSH 7.3 for many reasons.
The -J option alone is worth the upgrade. It's just the thing. The thing is, there's also a thing that was used earlier on called SSH agent forwarding to forward the authentication, the private key through the bastion host to other bastion host and to the target server. You don't want to use that anymore. There are attacks for that. If you're still using SSH agent forwarding, please turn that off and switch to more secure authentication methods.
Yep.
Any questions on this? quick one, yes.
Do we have a mic?
Wait a second for the mic, please. I've been rather fast, I know, sorry for that.
On the first proxy connection you did, it didn't ask for the host 2 password. Why?
Because the forwarding forwarded the tunnels 1 SSH connection through the other. So, and you start at your local PC. So it connects to the first to the first bastion server, connects through with the private certificate, does the normal authentication, and then it tunnels through the second connection from your client all through, and with that
and
you can securely forward the...
Okay, thank you.
So you're directly connecting through an SSH tunnel with an SSH tunnel.
With an SSH tunnel.
Yeah, you can multiply those. Keep in mind, if you're going like 16 hops that way, a single byte will give you 200 megabytes of traffic. So you may want to keep that number at a reasonable count.
Second one, and then we will...
Yep.
Lovely option, -J. So let's say only one of the hosts has your private key, has your public key in it. The other three ask you for a password. How would it look?
It will just prompt you for the password.
Each one of them?
Yeah.
Okay.
Okay.
Okay. How much time do we have? There still? What is 20 minutes. We still have 20 minutes.
We're way too fast.
Yeah, key authentication is just too fast.
Yeah.
We should have went for slower key exchange algorithms that take more time. That
We should have used Austrian bandwidths to demo.
Oh yeah.
Okay, so what's next on our list?
What's next?
I've lost.
Yeah, now you've seen Bastion hosts, also quite conveniently, and a few other nice, funny things you can add to your client config. For example, there's been a rather unpleasant discovery with SSH 5.4 to 7.1, including with an undocumented feature of the SSH client, which ended up with 2 CVEs, allowing an attacking host to steal key material from a client, which is rather not nice. It was fixed in 7.1 P2, patch level 2, yeah. It's an undocumented configuration option called use roaming. You want to set that to no on your client. It's not valid for the server, you don't need it there. But if you're not on a recent client version of OpenSSH, just put that into your general config to prevent any attacks from rogue servers, malicious servers to your client. Servers are not affected by this. Of course, if you can upgrade your OpenSSH, it's even better. It doesn't hurt on more modern versions. Of course, if you tweak a lot with your key exchange algorithms like we've seen before and your ciphers, you might find that some things are not working as expected. Of course, we always expect things not to work. This is why we have a strategy for debugging things.
We do have a strategy.
No, we have debugging. At least we have a problem to play with.
Yeah.
So if you're not sure if your SSH config options are actually sticking and if there's the right order of them in your config file, you can use SSH minus capital G. I have no idea what that stands for, but it's good.
Config.
Probably, yeah. And this will help you to see which config options actually apply to that specific connection. So it will combine everything from the global etc SSH config file to your .ssh config file, your host's asterisk entries, which apply to all host connections, and of course your specific host, this is my beautiful server, host. All those combined, you'll end up with a long list of options that you can see. And this is how you find out if your config probably has a problem with ordering or sorting to see that. You want to show that?
No.
You don't want to show that. You can imagine it's a lot of gibberish. Of course, if that does not help and you're sure, well, my config is actually fine, you surely have already used SSH-v for verbose mode, and the verbosity can go up to V, which is very, very verbose. It gives you a lot of debug output, but with those two, you should actually be fine with finding any problem that arises when connecting with the client to a certain host. Of course, you're lucky when you only have to deal with OpenSSH. I've heard there are other SSH clients out there, and even proprietary servers. Dare I say to use them?
Give me just one more second. You can of course use SSH minus triple V to debug the connection, but you might want to use a ping beforehand or something. I mean, you can use triple V to debug that you're not having any network connection at all, but it's usually faster to just ping before you do a triple V SSH.
Like the usual network cable without the clip that has just slightly
You mean the
slipped out of your port.
HP switch, special switch cable?
Yeah, or the special laptop safety cable. When somebody trips over, it just falls out instead of grabbing your laptop as well.
Sorry, I interrupted you regarding legacy systems.
Legacy systems. Does any one of you use legacy systems?
Windows.
That's not a system. That wasn't even a system.
That's legacy.
Yeah, but even on Windows 10, you can now have the Ubuntu subsystem, which is probably the only Ubuntu without systemd. So, yeah, you probably have probably any one of us has this old Solaris box somewhere, or HPUX, or Next Step, or
Iris.
Iris. Silicon
oh,
graphics.
yeah.
Anyone using Silicon graphics still? Not even the museum has one. They're great. There's ways to deal with legacy systems without messing up your whole config, because you can just make a config entry in your config file for host vintage box, and you don't have to write out all the bad stuff that this box supports, because somebody actually might update that box at some point. So there's a nice config option where you can add a specific type for key exchange algorithms to your general config by just prepending it with a plus. So if you add those 3 lines for any connection with the vintage box, you will also support Diffie-Hellman group SHA-1 and triple DES in CBC mode for encryption without having to change your general config, or only allowing that one should some better options apply at the moment. So this is a nice way to get back on track with the vintage box without having to mess up anything else.
Right. So the thing with this talk is that we were unsure on what really qualifies for advanced SSH. What we have shown you so far are things that the general population, we asked 100 sysadmins what advanced means, and this is what we came up with as, yes, this is advanced. I mean, there are a few obscure things like, okay, I want to use Kerberos and stuff like that. But that was the general, what we have shown you so far, the general agreement on what advanced SSH means. So we're a little bit ahead of time, unfortunately. Yep. So we would switch it over to questions, and if you have any questions regarding SSH, we will be happy to answer them now. Or
at least we'll try.
Yeah. Otherwise, grab us afterwards with a beer, and we will happy show you the things we skipped over with the config file and private public key and stuff like that.
If you approach us with a beer, maybe try to be the first one with the beer and not the 7th, because I would not take any SSH advice from myself after 7 beers.
Questions? Do we have a microphone?
We do have a microphone.
So make yourself noticeable. You can also ask questions for an absent friend if you don't want to ask yourself. So,
about challenge response, you showed how you can implement Google Authenticator, some RSA and time-based thing. Suppose I or a friend wanted something simpler. So just a challenge that where the response is calculated in somebody's head, right? So let's say super simple example. It shows me 10 letters, I should respond with the 5th of those letters. How difficult is it to implement something like that? Do you have to write a PAM module, or how would you do it?
Yeah, it's easy. Write a PAM module, yes.
Yeah, but getting a PAM module of that complexity is probably just a few lines of whatever programming language you like. So that should not be too hard. I'd probably search on GitHub for something like that
search and replace.
Maybe an absent friend has already written something that you can use, or at least easily patch to your liking.
Over there. Quick, push. Run,
Forrest, run.
Okay, so Google Authenticator seems cool. Haven't heard of it before somehow. Okay, so two stupid questions about it. Do you need to have a Google account? That's one. And the second one, do you have to agree to Google license agreement, the one that says you are okay with them selling your data to use it?
If you have a stock Android phone, you have probably agreed several times to the Google license agreements and stuff like that. For operation of the tool, you don't need any network connection. There is no data transmitted, neither from the application nor from your server. So it's really just code that generates this number. It's not that really not that hard.
Yeah. Also, the algorithm used is standardized, so you don't have to use. It's just a commonly known phrase, Google Authenticator. There's many other applications that implement the same algorithm, so you don't have to use the one from Google. It just happens to be available free on iOS, on Android, and other phones.
That the algorithm itself is a RFC, I think?
I think it's RFC, yeah. And for example, if you use an iPhone like me, there's also 1Password, which implements the same method. And you don't need a Google account for this. You don't need a network connection, you don't need a Google connection or anything. What we've shown you here with scanning the code, that's actually from the initial launch of the application where it greets you with the welcome screen. So use whatever application you prefer. There's probably some open source things on F-Droid that just do the same. So.
Yeah.
Is there any asymmetric algorithm strong enough against quantum computers?
I lost you after strong enough for, or after?
I mean, resistant to quantum computers.
Symmetric algorithms are actually not...
No, asymmetric.
Asymmetric.
Yeah.
I don't know of any implemented post-quantum key exchange algorithms like X25519 or something like that. At least not in OpenSSH yet. They're probably being added at some point, but not at this moment.
A follow-up. Do we allow follow-ups?
And just additional question. What do you think about N-through algorithm?
I didn't...
N-through.
Andrew?
N-T-R-U.
Yes.
Okay, fine. Thanks.
Sorry.
Come to us after the talk, please.
Yay.
Yeah.
Question regarding the Google Authenticator. Would it be possible to chain load them so we would actually need more than one device to actually give access to a machine? Similar to launching nuclear missiles, where you have two people that actually have to turn the key at the same time.
At least I haven't tried.
You basically clone. If you build the PAM module by yourself, you could just rename it, and yeah, should work.
Okay.
Thank you. Probably have to just patch the file name that Google Authenticator looks for in your home directory, and if you add multiple of those, that should probably give you what you need to launch your codes.
Thank you.
Any more questions?
Anything we missed? Anything you think is advanced and we skipped?
So we know what to prepare for next year.
I thought we were doing Kerberos authentication next year.
Yeah, with certificates. No, we're not. Okay.
Somebody said, "Oh, you do it." No, anything else over there? Hello. Ooh. Any
Still alive?
questions over there? Still awake?
No?
No?
Yeah? Later? Oh, that sounds like beer.
Come on.
There's still time.
Yeah.
Is there?
No.
There's no time.
Okay. Okay.
What beer do you like?
We just wanted to thank those two people because they helped a lot with all the crypto stuff. So thanks, Tribika and Holti. You're awesome.
Welcome.
And thanks for your time and putting up with us. You'll find us on the Twitter.